Okay, so thank you for having me at the webinar today. As Neil said, I'm Kate Mooney, and today I'm talking about a study I've recently conducted, which is called Longitudinal Pathways Between Socioeconomic Status and Educational Attainment, Mediation by Executive Functions and Processing Speed. And also co-authors on this study are Rachel Chung, Sarah Blower, Richard Allen, and Amanda Waterman. So a bit of background, first of all, we know that social inequalities in children's educational outcomes are consistently demonstrated. There's a consistent and persistent socioeconomic attainment gap that we constantly see in various educational reports and also in the news as well, and different academic studies too. So here's just a splash of different reports that find a really similar image that there is this socioeconomic attainment gap. And I've just picked out one particular statistic from the Education Policy Institute, where they show that social inequalities in children's attainment begin really early on, and they actually grow as children progress through school as well. So by the time children are in secondary school, we can see that the gap actually grows to an age difference of about 18 months between children who are disadvantaged and non-disadvantaged. So we know that this socioeconomic attainment gap exists, and we know that it hinders further progression as children become adults. And that's in terms of both their future education, employment, and health. And we know that about approximately half of the association between earlier and later occupational class can be explained by mediation via educational attainment. So how well we do in school really determines what we go on to do later on in life. And that's not just a problem for the individual, but also for society as a whole. So educational inequality leads to reduced economic productivity and increased income inequality too. And this perpetuates this cycle of inequality that we have in the UK. So we know that there's this strong relationship between socioeconomic status and educational attainment, but we don't really yet have good research evidence on exactly why that might be. Some researchers might focus on the environmental aspects of socioeconomic disadvantage, such as access to resources and opportunities or differences in the home learning environment. But what I'm really interested in is understanding the actual underlying abilities that might be affected by disadvantage, and then how do those abilities later influence academic attainment. And my perspective is that if we can understand these pathways better, we can potentially provide educational support to children in the classroom. There are lots of different abilities that might mediate this pathway, but one of those is executive function, or EF, I'll refer to it as from now on. And EF is our processes responsible for purposeful, goal-directed behaviour, and it's made up of two core components, which are described here. One of those is our working memory, which is our ability to storage and manipulate information over short time periods. I like to describe it as a mental post-it note. And another is inhibition, which is our ability to inhibit dominant or automatic responses. A separate ability is that of processing speed, which refers to how quickly we process information, and that's normally measured using a reaction time task. And we can see theoretically how these things might lead to differences in children's educational attainments. So in terms of the research that has looked at whether EF mediates the association between SES and broad educational attainment, there is research showing that it does appear to mediate that relationship. And there's also research looking within the different components of EF as well. And generally, studies seem to have found that working memory significantly mediates this relationship, and that's in comparison to other abilities, but there are some contradicting results out there as well. So there's this one particular study that found that the relationship between SES and attainment was not mediated via working memory, but it was mediated via inhibition. So there are some different studies there, but the reason for those differences could be due to the ages of children studied. And in terms of the research on processing speed, there are studies that look at direct associations between these things. So it does appear that childhood SES is associated with processing speed, and processing speed itself does seem to have associations with children's educational attainment. However, no studies have looked at whether processing speed actually mediates this association. And specifically, no studies have compared it to the role that executive function might have either. So coming on to this study and the rationale for it, There is this previous research which compares the different contributions of executive function, but some of that research does have limitations. Some of the studies are cross-sectional, which isn't appropriate for modelling longitudinal processes. Many of the studies use approximate educational outcomes. So rather than using children's actual attainment in their educational records, they're using standardised measures of attainment, which is useful to know about, but doesn't tell us about children's actual qualifications. And none of the studies pre-registered their analyses either, so we can't tell how exploratory or confirmatory these studies were. No study has looked at whether processing speed mediates the relationship at all. And finally, a lot of this research predominantly relies on higher income groups and white ethnic groups as well. So there's a real lack of diversity in this kind of research. So what we decided to do was test the different contributions of both EF and processing speed abilities to the relationship between SES and educational attainment. In our first model, we tested whether global EF and/or processing speed mediated the relationship. And in the second model, we tested whether the two core components of EF, which are working memory and inhibition, mediated the relationship. So the design is a secondary analysis of a longitudinal cohort study, and the cohort study is born in Bradford. For those of you who don't know, Bradford is a city in northern England and it's situated on the map here, quite near Leeds. So born in Bradford, or BIB, comprises about 13,500 children and their families, and they were recruited when mums were pregnant between 2007 and 2010, and they've been followed ever since. So BIB have links to routinely collected educational data, which is what I'm using in this study, but they've also collected various data collection waves along the way as well. And one of those is called the primary school years wave. And that wave in particular is instrumental for this study. And so we'll describe that in a bit more detail. And Bradford is a really interesting city in terms of its socioeconomic diversity and ethnic diversity too. So in fact, approximately half of the families in the BIB cohort are from Pakistan, and Bradford itself is a really diverse and multicultural city. And Bradford also has very high levels of socioeconomic deprivation. So you can see here the picture of the index of multiple deprivation. And you can see that many of the neighbourhoods within Bradford do fall into the most deprived decile in the UK. And overall, it is the 13th most deprived local authority in England. So moving on now to the measures that I've included in this study. On the left, you can see that the BIB baseline questionnaire was administered to mums of children before they were born. And we are measuring socioeconomic status taken from questions that were collected in the baseline questionnaire. And I'm using a previously validated measure of socioeconomic status, which is a latent class construct based on various aspects of socioeconomic position. Also from the BIB baseline questionnaire, I'm measuring whether parents were born in the UK or not. And then at age 7 to 10, you can see that the BIB primary school years sweep took place. And this is where researchers went into classrooms and tested whole classes of children on various cognitive measures. And I'll describe those in more detail on the next slide. And then at age 10 to 11, you can see that we've got the linked data from the National Pupil Database. So from that, I'm measuring child ethnicity, child gender, child English as an additional language, and child age in months too. And then importantly, we've got the outcome variable for this study, which is educational attainment. And that is a key stage 2 assessment, and it's measured with continuous scaled scores that range between 80 and 120, and they relate to mathematics, reading, and a grammar, punctuation, or spelling test. So now here are the mediating variables from the primary school years data collection wave. So you can see that there are 5 different tasks that I'm looking at in this study. The 3 tasks on the left are all tasks of working memory. So the first task was a measure of forwards digit recall, where the child heard a series of digits and had to repeat them back in the same order. The second task is backwards digit recall, which was the same but backwards, and core C is a spatial sequence task. The next task on there is the task of inhibition, which was measured using a flanker task. And this is where the child had to identify whether the arrow was facing in the right direction or not. So those 4 tasks together are measures of executive function, but the 3 tasks on the left are measures of working memory. And then finally, there was a measure of processing speed as well, where the child had to quickly count how many red triangles were presented within a trial as quickly as they possibly could. So moving on now to the analyses. Participants were eligible for the analysis if they had available data on any of the exogenous variables. And when I say exogenous, I mean any variable which is not affected by anything else within the model. So in that diagram, you can see that it's the variables at the top of the diagram. I pre-registered the study and the analysis plan, and I also pre-specified a causal structural model using a directed acyclic graph. And this is a picture of that, and I made that using the software Daggerty. So it's a really useful way of specifying how you think all of the things in your model might be related. And then it's really useful telling you what it's essential that you control for. So I use structural equation modeling for the analysis, and that's because it can answer different related research questions at once, and it uses a combination of latent variables and indicator variables. And I did 2 separate models, which I will show you in the next slide. I used data for cleaning and merging and conducted the analysis in R. I bootstrapped any of the mediating effects and used full information maximum likelihood for missing data. So this is what the analytical model looked like. And this is the first model where we're testing EF versus processing speed. So you can see that we're testing a direct effect of socioeconomic status on educational attainment. And then we're also testing 2 indirect effects, so via executive function and via processing speed. And also here you can see that executive function is measured with the 4 executive function tasks made up of 3 working memory tasks plus the inhibition task. And you can also see that educational attainment is measured with the 3 indicator variables of reading, math, and grammar, punctuation, and spelling. The model also adjusted for the effects of the covariates in the top right, so ethnicity, age, gender, English as an additional language, and parent country of birth. And then this is the second model. So this model is really very similar, except all we've done is taken those 4 tasks from the executive function and divided them up. So we're testing the different contributions of working memory versus inhibition. And this model controlled for exactly the same things as the previous one. So onto the results. There were 4,201 individual children who had the right data available to be included. At the parent level, you can see the different socioeconomic diversity that's included. And you can also see that a very large minority of the parents were born outside the UK, so 43%. At the child level, you can see that 56% of the children were white British, 28% were Pakistani, and 16% were other ethnic minorities. Most of that 16% were children who were Indian or Bangladeshi. So you can see that this is a really ethnically diverse sample. You can also see that exactly half of the children were recorded as speaking English as an additional language. But Bradford is quite a unique population to work with in that the majority of these children will be bilingual. So they might speak both English and, for example, Urdu fluently, rather than having English as their second language. So moving on now to the model results. So this is the first model, and in the top left you can see the path diagram, and any of the solid lines indicate significant effects and the one dashed line indicates a non-significant effect. On the right-hand side, we've got a table of the standardized parameter results, and I've just included the key ones for this presentation. We can see that the model fit values generally indicated adequate model fit, which means that the model appears to be an adequate representation of the data, and that some things were just below the acceptable range. So it indicates it's not the best representation of this data. So if we look at the total effect at the top, the total effect is the combined effect of all of the paths, and we can see that that is significant. And then looking next onto the key parameters here, so the direct effect. The direct effect between SES and educational attainment was significant, and it's at 0.152. The indirect effect via executive function was also significant, and that's at 0.109. And the indirect effect via processing speed was not significant at all and was very small in magnitude too. And then here's the second model. So this is the model where we've divided up the executive function tasks. And here we can see that the total effect is very similar, as is the direct effect, and that's significant as well. And then interestingly here, the indirect effect of SES via working memory towards educational attainment is very similar in magnitude to the one via executive function. In fact, you can see the mediation ratio where it takes up 39% of the total effect. And the indirect effect via inhibition is not significant at all, and it's obviously very small in magnitude too, so that doesn't seem to be playing a significant role here. And the model fit values were generally more favourable in this model, which indicates that this is a better representation of the data. So to summarise, because that was lots of information all at once, the first model indicated that executive functions significantly mediated the relationship between SES and educational attainment, whilst processing speed did not. And the second model indicated that working memory significantly mediated the relationship between executive functions, the relationship between SES and educational attainment, whilst inhibition did not. So coming on now to the conclusions. The key finding is that working memory was a partial mediator of the relationship between SES and attainment, and there was no evidence here that processing speed or inhibition mediated the relationship. There was some previous research in this area, and this does appear to build on the other findings, and it does appear to indicate that working memory partially mediates this relationship, and this is quite consistent with the previous literature. The implication of this is that the reduction of social inequality itself might reduce differences in children's working memory, and then hence that might reduce educational inequalities. But in the absence of that, we look to ways to support children with their working memory in the classroom, because that might be a promising avenue to close the socioeconomic attainment gap. Some researchers have tested methods of working memory training, so things like brain training programs, but they generally find that they don't seem to work. If they do make any difference to working memory, the effects don't seem to transfer to things like educational attainment. So we really need to be looking to other ways of supporting children with working memory difficulties. So finally, some limitations. This is obviously an observational study design, and we need to exercise any caution when discussing causal nature of the pathways. I do tend to slip into causal language when I'm talking about this out loud, because if I don't, I will tie myself in knots. But obviously, we need to be quite cautious when describing whether we believe these pathways are causal. The sample are from one city in the UK, which has high socioeconomic deprivation and high levels of ethnic diversity too. So whilst the findings might not generalise to the UK as a whole, they probably are quite useful for cities which have a similar demographic. Not all of the children had the educational outcome data available, and that was just because not all children had reached the age where they'd completed Key Stage 2. So it might be beneficial to repeat this analysis when the children are older. And for future research, we could be investigating whether the pathways are causal using a randomised trial. And there is some interesting work going on in America that is doing this at the moment. And we should also be collecting repeated measurements in longitudinal samples to build our understanding of these mechanisms. And that's because there were some contradictory results with previous research around the role of processing speed. So it might be that processing speed and/or inhibition play more of a role in younger children, and working memory becomes more important in older children. But we just don't know that, and that needs to be tested. And finally, we should really be finding ways to support children with working memory difficulties in the classroom. So finally, thank you to everyone who makes Ball in Bradford happen, and also to all the research assistants who have collected the data over the years. And thank you again to the co-authors, Rachel Chung, Sarah Blower, Richard Allen and Amanda Waterman. And thank you for all of you for listening. And if you're working on anything related to this or want to reach out, then do get in touch. There's my email address and my Twitter there as well.